Okay, so we're going to work out the other ones in the notes that we didn't get to last week. So this third one, it says the absolute temperature of, so there's 150 cubic decimeters, and it tells us here that the absolute temperature is doubled. And then notice that it says that it's at a constant pressure. So constant pressure means that pressure is not in our equation. And then it asks us, what is the new volume? Okay, what is the new volume? So if I kind of label these, so the temperature's doubled, so they're going to let me pick on my own numbers. So again, pick easy numbers. I'm going to pick 1 and I'm going to pick 2. And then this would be my V1, and I'm solving for V2. So since I have volumes and temperatures, this is going to be a Charles law equation. And so I can do V1 over T1 equals V2 over T2. And then I need to cross multiply. That's always the first thing I do with this type of equation. So I have V1 times T2 equals V2 times T1. And since we're solving for V2, both sides would need to get divided by T1. So that cancels out here. And then I can simply plug my numbers in. So V1 is 150. T2, we picked 2 because it doubled from the original one. And T1 is 1. So 150 times 2, that's 300, sorry, not Kelvin, 300 cubic decimeters for the new volume. Now, I will say that you can do this without math. If I understand that according to Charles' law, volume and temperature have a direct relationship. So if the temperature goes up, the volume goes up by the same amount. So because they said the temperature doubled, that means the volume also has to double because of their relationship. So you can explain it with words by simply saying that volume and temperature have a directly proportional relationship. Therefore, if the temperature doubles, the volume will also double, and the new volume would be 300 because that's 150 times 2. All right, so now I'm going to do number 4. Clean off some space here. All right, so number 4, what happens to the volume of a fixed mass of gas when it's pressure? Okay, so it's pressure and its temperature, absolute temperature. They're both doubled. What happens to the volume? So this seems a little hard, but it's really not because they're letting us pick all the numbers. And so if pressure and volume are both doubled, if pressure and temperature are both doubled, that means that nothing is constant. And so this is going to be a combined gas law problem. So it's kind of like with your powers combined, okay? So you put together Boyle's, Charles, and Guy-Lussac's law. And so that's P1 times V1 over T1 equals P2 times V2 over T2 when we put all of them together. And so they want to know what happens to the volume. So you don't have to do this equation. You can. But if we think about the fact that we know volume and pressure are inverse, right? So if the pressure doubles and these are inverse, so that means if the pressure is times 2, the volume will be multiplied by 1/2. It'll be divided by 2 because they're inverse. Then if I go and consider the temperature, volume and temperature are direct. So if the temperature is doubled, the volume will double because they're direct. So if I divide by 2 and I also multiply by 2, then what happens to my answer? Well, that ends up canceling out because if I divide something by 2 and I also multiply it by 2, that's going to cancel out, and so the volume would actually not change. So you would say the volume would not change, and then your explanation would simply be that pressure and volume are inversely related, so doubling the pressure would divide the volume in half. But volume and temperature are directly related, so doubling the temperature would double the volume, and those two things both happening would cancel out, and the volume would remain the same. All right, we got one more here. Clear some space off. Okay. All right, so this last one, it says the volume of an ideal gas at 27 degrees Celsius is increased from, let me switch colors, 3 cubic decimeters to 6 cubic decimeters. And then it says, at what temperature in degrees Celsius will the gas have the original pressure? Okay, so on this one, we are going to be solving for a temperature, okay? And so if it has the original pressure, that means the pressure is staying constant, okay? And so that means pressure is not needed for the equation. And so this is only going to be volumes and temperatures, which is Charles's law again. And so what I need to do is look at these volumes. What's happening to the volume? Well, it went from 3 to 2, so the volume doubled. And if I know that according to Charles' law, volume and temperature are directly related, so if the volume doubles, that means the temperature is also going to double. The only thing is you have to convert this temperature to Kelvin first before you double it, because it's always the absolute temperature. So I need to add 27 to 273, which would give me 300 Kelvin. So now that one is going to double, and it will be 600 Kelvin. But if I go back up here, remember they said they want the temperature in degrees Celsius. So my final answer, I need to subtract 273 from this again. And so I end up getting 327 degrees Celsius for the new temperature in Celsius.